Alright, we're back to part 2 here on building the low voltage circuit board for the HT-37. Let me get my camera set up here a little better. Here's this circuit board here. This is a newly designed board I just did here today. I'm going to get closer here so you can see better. Let's see, get over right there. So you'll have to put this on pause to study it. Then I'll come over here and put comments on it. Put that on pause and get that information too. Okay, that's the new board. And this is the schematic of the power supply. And I can't get the whole thing in there. Well, I get it like this. Let's see here, right there. I don't know if you'll be able to zoom in on that or not. But anyway, that's the deal on that. So this is the original board, the prototype board right here. And you can see that the new board is going to be totally different. The parts are fit on the same way, same size and all that, but you got a lot more copper on the board. This board here was all hand drawn. And there's the two grounds coming out for the low voltage. And this is the setup here. Now, this board's going to give you a higher voltage rating and a higher capacitance rating. So your filtering is going to be much better for the 300 volt supply and the 150 volt supply. It's going to be more better filtering. And the board is going to have a higher voltage rating. So, because these are 450 volt capacitors, and there's two on each side of the filter here. This takes the place of the big can that's down inside the transmitter. And we'll go over here and look at it. That's the can right down there. See, takes the place of that. And there's your can right down there that we're replacing with the board. The can's going to stay in there because you want it to look more original, but everything's been disconnected, and the wires that were on the can are spliced together. So there was two capacitors in there. See. Two capacitors. Well, we're replacing two capacitors with four capacitors. You got two in series, and these things are 120 microfarad of 450. Now, what was in the can, I think it was 20 microfarads each. So this is going to give you a lot more. This is going to give you equivalent to 55 microfarad filtering for each side of that can. And then you got your brand new your equalizing resistors right here. These are three waters. You only need 3 wires because the highest voltage is going to be 350 volts maybe. All right. And so this will be mounted sideways now. He's sitting like this into the transmitter. Now you see I got these standoffs here. And where my little, I had something right here. The standoffs right here. I got those. Sometimes I had some old computers or some old equipment, and I was removing the motherboards, and I found these down underneath, or holding the motherboard up off the steel case. So I salvaged them. But if you don't have these, don't worry about it. All you need is a 440 or whatever bolt go through there. Put three or four washers three or four nuts on here, okay, and tighten them up, and then the bolt will stick out like this, the threads, so that when you go through the side of the transmitter, and this thing's going to be laying right in there like this. See, that's what it's going to look like right inside here, with your resistors on the bottom side. But that's the low voltage, and your high voltage is going to be over here. So I got that done. The only thing is you gotta remember to get the polarity right. You got plus and minuses on this thing, and of course the drawing here I have that on here on the drawing. You see the pluses and minuses up here, right in here, plus and minus. This capacitor is going right across here, and then your resistors right here are going across, and they're right here. See. So now we got the board finished. One comment on the boards here. This is the high voltage board, by the way. What you do is when you get the dimensions there, and I have them on the drawing. This one's 4 3/8 inch long by 1 1/2 inch high or width. And you cut the pattern out here, and you lay it across the board, and you got the board cut the proper size, and then you take a punch, and you punch down through the print here, and it'll put a dimple on your board. Then you can etch your board, and then after the board's etched, then you can drill a small pilot hole through there, and get your holes in there. Then you want to see if your capacitors fit in there. If they don't, you can make a little hole a little bigger. But I already pre-tested this board, and the capacitors all fit onto the board. But I have a zero tolerance. they just fit. I found out on the high voltage board here, the high voltage, which is this one. This is the third, part 3 when I do this one. We're in part 2 of the rebuild here. But on part 3, this board here, you can go as much as a 1/2 inch longer. But the overall, both boards have to be able to fit inside the case here, inside the chassis. So now what I'm going to do is, we got this thing built. What we want to do is see if it's going to work. We're going to test it at low voltage. Each section. So this is actually, these two here are only one side of the metal can, and this is the other side of the metal can. So it's only equivalent to two capacitors, but these two are in series. These two are in series. So we're going to check it on a low voltage and make sure everything is working. And if it is, then this thing is ready to be put into the transmitter, and I can fire it up without the output tubes, and everything else should work. VFO should work, the sideband generator should work, your multiplier, frequency multiplier circuit should work, and everything. Your heterodyne oscillator should work and all at it. So that's what I'm going to do. I'm going to show you how to just pre-test this on low voltage, and then you'll be ready to install it. So we'll come back here after I get set up.